one executive asked me, how do you trust AI? So,
Good question.
yes, very direct question. So I gave him the honest answer. I told him, you can't trust AI. Even if agentic AI can act, autonomously, it can plan and everything. You still have to, validate everything AI produces, because the accountability stays with human. Uh, and then he pushed back, and it was a fair push. He said, we don't have the resources to babysit, AI at every step, because after each run, you have to human needs to has the accountability, need to review the output. So he said, what do you suggest? I said, you use AI to validate the result and let it reiterate. And then he landed a great question. He said, so you write code with AI, then you have AI validating it, then AI tests it and AI debugs it. Can't you just have AI make it right, first time? Yeah, I mean, it's a good question. And, I would ask the same question. But my answer is, if we look at ourselves, humans do not get everything right, the first time either. Think about how software is developed, without AI. Product owners and developers, they refine requirements together, because, we cannot understand the requirements first time because it's very summarized and it could be, abstract. So by talking to each other, we can, refine the requirements together, and that's a natural process. And developers and testers, it's the same. They work through, functional issues by discussing it and understanding it. But every iteration, they understand better what the problem is, and that's how we resolve issues. Look at front end and back end teams. They align on data and APIs the same way. So we are already working through cycles of checking and improving. We are already doing it. AI simply makes those loops visible. But then, the key difference is that AI can run many more of those loops much faster. So rather than human reviews everything AI generates, AI can check and improve its own work before, a human reviews the outcome.
Right. So here's my worry with that answer, and it's the security worry. If AI checks AI, who checks the checker? It sounds a little bit like marking your own homework.
Good challenge. I have two answers. First, the split of work matters. The AI's self-checking loop, it replaces the human checking every intermediate step, not the final step, the intermediate steps. It does not replace the human validating the final outcome. And this belongs to human. A human signs off at the end, and you validate the destination, not every turn of the wheel. So that's the first thing. Second thing is that the checker is not the AI marking its own homework. Humans decide what the outcome should be. So the loop checks the work against our rules, not against its own, opinion or rules. Or we can also use a different model to check. It's not marking its own homework. So this predetermined outcome is called the eval criteria.
So let's quickly flip back to my question about what is token maxing. I believe Fortune magazine declared that token maxing is dead in May, and yet here we're about to talk about more tokens.
Yes, it can be confusing. Let me first explain the word. A token is the unit AI models work in, equivalent to roughly a word and a half of text. As you know, you pay per token. So token use is basically how much thinking you buy from the AI. Early this year, token use became a status game. So New York Times reported leaderboards inside Meta and OpenAI, where engineers compete on who burned the most tokens. NVIDIA's boss, Jensen Huang, said he would be alarmed if a $500,000 engineer did not spend $250,000 on tokens. This is called token maxing. So it's a status game. Then came the backlash. Some Amazon employees were reportedly running agents on meaningless tasks just to keep their numbers up, because their managers were watching the leaderboard. And by May, Fortune magazine ran that headline: "Token maxing is dead," and companies did not get the return.
Crazy stuff. So I guess Fortune's kind of right then.
Yeah, I mean, yeah, I agree with Fortune in some respect. So I would say Fortune is half right, but the other half matters. Um, this is the most delicate point I will make today. So let me take it slowly. The reason to use more tokens is to reduce the need for constant human supervision. So if an agent requires a person to review every intermediate step, it's not delivering much efficiency. So you want the agent to arrive with a better first cut. How do you do that? You give it a clear checklist of what good looks like and let it work through several drafts on its own. So writing the draft, checking its own draft against the checklist, fixing all the mistakes before showing the human the final result. You have to burn a lot of tokens necessarily, because in long chains of work, small errors compound very fast. For example, imagine a task with 1,000 small steps, and each step, works 99.9% of the time, so it's almost perfect. What is the chance the whole thing works end to end? If you multiply 0.999, 1,000 times, it's about 37%, not 99. That's why self-correction after each step is important. It's not a luxury. It's the only thing standing between you and the compound failure.
So where did the token maxes go wrong?
Yeah. So what I'm trying to say is that burning tokens is necessary, but the examples I gave you, the Amazon examples, they inverted the cause and effect. So token count became the goal in token maxing case instead of the result, the effect. So without a clear specification for what to build, a way to check if it's actually good, and the right structure to keep it on track, the process of just pushing the AI agents to act and let humans fix later, it's just the inefficiency with a big invoice. So without carefully designed specs, evals and harnesses, it's basically inefficient, and that's what died. Good Hart's law states when a measure becomes a target, it stops being a good measure, and I completely agree with that. Heavy token use with sound engineering underneath. So all these engineering concepts we spoke about earlier, clear specs, evaluation, criteria, guardrails, a harness, then it's not a waste. That's exactly how you reduce the human babysitting. Breaking work into small pieces, small tasks, each with a clear spec and clear evals. That's harness engineering and loop engineering that I explained before. So if you do that well, then high token use follows naturally. So bottom line is this: token maxing is a result, not a goal. So if your token bill is high because your loops are well engineered, and producing good results without babysitting, that's good. If your token bill is high because it's on a leaderboard, then you have a problem.
So a big token bill can actually be a good thing rather than a race.
Yeah, I agree. So a big bill is okay when it's structured, engineered use of tokens with clear goals, built-in checkpoints, and defined limits. Pays for you're paying for quality. A waste is unstructured, ad hoc, open-ended use that just pays for volume.
Right. So the machines write the code, the loops run overnight, and what happens to the humans? What happens to our people was one of those really important concerns for people at the lunches, right?
Yes. So yeah, they were concerned. They asked this kind of question a lot. Uh, I mean, the role changes, from, the developer's role changes from coder to orchestrator. So you spend less time typing and spending more time setting the goal, designing the entire system. You write the acceptance criteria, the evals, and directing the agents so that they produce correct result. So and new jobs are appearing for deployed engineers. People who sit inside a customer's business and ship AI solutions on the spot. And agent managers, people who direct and govern whole fleets of agents. In a sense, everyone becomes a manager from day one. So my message to the executives and business leaders is simple. You do not need to replace people, but people who learn to direct agents will be far ahead of people who compete with agents. The organizations that upskill now, that rethink the roles now, will do far better than the ones that wait.
Oh, that's good news for us humans. Thank goodness. Executives also asked you, we've rolled out Copilot, where do we go from here? And they had no map. I believe you gave them a map. Can you talk us through that?
Yeah, the real problem is not tools. Everyone has tools. The problem is there is no shared mental picture, um, a map. So no way to answer where are we and where next. The buzz was multiplying faster than anyone can build a map. So I recommended a 5-level model for executives to follow. Um, I adapted it from Ann Muraco, a well-known venture capitalist from the US. It's got 5 levels. Level 1 is personal productivity level. Each person uses AI with their own context and their own tools. So tools like Copilot, Claude, ChatGPT, and it's for individual wins. But it doesn't impact the whole organization. If these people leave, then the organizations don't have the AI expert anymore. Level 2 is team workflow level. So AI works with the team context and team tooling. So it includes a shared process, not personal habits. Level 3 is the organizational infrastructure level. So AI is wired into organization's own context, its data, its systems, and processes. So now it's infrastructure like your network. Level 4 is the self-learning organization. Here is where the engineering story pays off. Level 4 is harness engineering at the level of the whole organization. So the rules are now built around business processes. The organization improves inside guardrails continuously. That's level 4. So level 5 is the self-driving organization. It's a loop engineering at organization level. So loops of agents running the whole processes with humans setting direction and validating outcomes.
And where do you honestly think most customers are at the moment?
I would say most companies are at level one in New Zealand and everywhere else. Some are working towards level two, which is the workflow automation. The global frontier firms like OpenAI, Anthropic, they are said to be around level three. Um, Nobody's at level five. Um, and I want to be very clear: level one is fine. It's a starting point, not a failure. The real risk is not knowing, the ladder exists. Once you can see it, the questions from business executives and leaders answer themselves. Are we doing it right? You can check. What are others doing? Mostly level one, some at level two. Where do we go from here? One level up. If you're level one, aim for level two. If you're at level two, aim for level three, deliberately.
What kind of uplift does it take for a customer to go from level 1 to level 2, for example? That's probably the jump most of our listeners are facing at the moment.
Sure. Level one could be our analysts each use Copilot. Level two could be our monthly report is produced by team workflow. An agent drafts from our data, checks itself against our quality evals, and a named person reviews and sign off. That's an example of level two. Same people, same tools roughly, but now it is a designed process with shared context, not a team of individuals carrying out this process separately on their own.
With my security hat on, here's what makes me a little bit nervous. Every level you climb, the AI gets more autonomous and touches more of the organization. Level 5, a self-driving organization, sounds awesome, but also like my worst nightmare from a visibility and potential catastrophic incident perspective. How do we govern all of this?
Well, let me tell you what one of our customers told me, because it is exactly your worry. The most common comment that the person received was um, their governance framework stayed at the level of principles, very high level. You should do this, you should not do that, and it stopped there. And they
So,
didn't know, yeah, they didn't know what to do.
yeah, and the landscape changes all the time, so it can't really stop. What do you see as the cause?
I can think of three reasons, and they compound. Reason number one: leaders do not understand AI deeply enough to write specific rules. And two, uh, AI changes so fast that specific rules are hard to write and even harder to keep updated. And three, enforcement breaks. So when rules are broad, every judgment call falls back on individuals, and those individuals cannot keep up. Not with the volume of questions, not with the speed of change. The rules all come back to individuals who cannot keep up, and that's the failure mode in one sentence.
Okay. I've heard you suggest internally that we should build governance around our AI use cases, design governance around our specific tools. How do we actually do that in reality when most people are just racing ahead and building stuff with their shiny new tools without even considering or caring about the long-term implications to maintainability, safety, and security?
Um, well, two things again. First, you don't build a new, empire. AI governance should live inside the existing IT and data governance structure. So, same, for example, same accountable people, same forums, same escalation paths, and one rule that never changes. A named human is accountable for validating AI output always. So that's the first thing I want to, mention. The second thing is that inside this existing structure, the rules are written per tool and per use case. Not one giant, framework that tries to cover everything and ends up covering nothing. For example, we can have a rule for coding agents, a rule for the customer-facing chatbots, another rule for the finance workflows. In this way, exceptions are handled in a controlled environment, and it's not banned or controlled. So within this existing structure, we can implement specific rules. This structure, the existing structure, prevents the sprawl, and this specific rules prevents the post on the wall. So we can have the both worlds.